Yeah, cheers, and thanks for hosting me. As Adam says, I'm Vice President at the IST, and although we might appear like a competitor organisation to the BCS, we're actually in a very similar space. This kind of stuff that Adam said at the beginning about what the BCS stand for, very similar for the Association for Software Testing. And in fact, about 18 months ago, maybe something like that, we ran a joint peer conference. The topic was, should the public care about software testing? There's a write-up on our website from myself and Adam. It probably won't surprise you to learn that we thought the public should care about software testing. And I imagine some of the stuff that we covered there will be kind of covered in Adam's closing keynote today as well. I've just come back from CAST, which Jonathan mentioned. That was our conference. The theme there was hands-on, and I found that really invigorating. And if you check out social media over the last few days, we've been tweeting out concise summaries of stuff that was going on at the conference. It's not an advert for IST, but we have a similar aim for diversity and inclusivity, and we operate a pay what you can model to encourage that. Again, check us out. If you want to talk more about it, come and see me afterwards. I am a tester at ADA, so the talk I'm going to do today will be about one of the ADA products, which is a symptom check-in app. And in a symptom checker, essentially what happens is you give a few details, you describe what your current symptoms are, it's a medical application, and then you're guided through a dialogue around 20 questions, something of that order, where you'll be asked about those symptoms and maybe a bit about the medical history, that kind of thing. And then at the end, you'll get a list of suggestions, so we call them conditions, things that you might have, along with a bit of advice, maybe go to the doctor, get yourself to the hospital. This is okay, you can treat yourself at home, it's just a couple of paracetamol or something. I joined a project that had started a couple of months earlier to, well, you saw it's quite a rich interface, to create a text-only interface, or create an API for text-only interfaces. So to provide a way for something like WhatsApp to integrate with the same kind of assessment question flow that you just saw in the image of. And the task was, as this says, create a presentation agnostic API. The graphics that I just showed, the client and the server side, kind of know quite a bit about each other. They're reasonably tightly coupled, and we wanted to decouple the client from the server. We wanted to have integration with text-based clients, as I've said, something like WhatsApp, but to retain that turn-based medical assessment. And of course, because it's the real world, there was a really short deadline for that as well. Room full of testers, no doubt. You're already thinking about what might you want to test, what might the risks be around here, what sort of questions would you want to ask, and who would you want to ask them of. Don't have time for all of those. I'm just going to talk today about one particular aspect. And this was what myself and Sunita, the other tester on the team, came up with, and that is, there's a massive combinatorial explosion when you think about the possible paths through the assessment space. There's any number of users with any number of ages. They can have any collection of symptoms with different degrees of severity for different lengths of time. You can ask different numbers of questions of them. They can answer those in different ways. The questions can be ordered differently. It kind of really explodes. But when you do an assessment yourself, kind of manually, you've just got one path through that entire space. And the kind of risks we're interested in thinking about were, let's say we find a bug on one of those paths and we fix it. How do we give ourselves any confidence at all that we haven't side-effected something else somewhere else in that massive space? How could we proactively go and look for places where you're in a particular state in this space? Something that usually works doesn't work. The answer to the question that normally just continues the flow breaks the flow. And how could we, given that this was a new API on a short deadline, how could we exercise it a lot before it needed to be used? The APIs for the existing products probably have had millions of assessments through them over the last 10 years while they've been developed. This would have had very few. And the suggestion I came up with was to build a walker. And what do I mean by a walker? Well, I mean, I'm going to make a client that can run unattended medical assessments. And it needs to be iterated and customized quickly because we're building this API and I want to be testing it as it's being built. And as I have a new functionality, I want to be able to change it. And as I have new questions, I want to be able to direct it towards those answers to those questions. And I also wanted, what is running unattended, to be able to highlight places that maybe a human should go and look. This is a tool for helping me to explore. This isn't kind of standard test automation, if you like, with like unit tests. And this is the algorithm that I came up with, the simplest thing I could think of that could implement a walker like this. So it's going to start an assessment, and the first thing the client will do is say, what card type is this? And a card type is just kind of internal name for the kind of question that the service is going to ask. So it might, card type might be text, and that's just presentation data from the server side. So all the client needs to do is say, okay. Or it might be input, and in this case, the service is asking for some data like a name or an age. And again, the client could just simply say, here's a random string or here's a random number, maybe within certain constraints, or maybe not, depending on what I want to test. And then there'll be a choice, and this is like a multiple choice, so there'll be a series of options, and all the walker needs to do is randomly choose one of those options. And with that kind of strategy, you can basically navigate through any assessment. So client starts, finds the card type, chooses the answer type. Is there another turn? Yes, okay, we'll go back around that loop. If there's no other turn, then stop, because we're at the end of the assessment. And so I built it, and I built it in Python because I was interested in learning Python. So this is more or less my first Python program. And while I was building it, I kind of noticed three interesting combinations of development and testing. Three ways in which they combined and complemented each other. And there's a bit grey between these things, but I think they're kind of interesting areas. So the first one I call navigation. And in that one, I was trying to build end to end from the start of an assessment to the end of the assessment. And I was kind of focused more on the development. I just wanted to get some kind of walking skeleton that would get me from one place to the other. I was prepared to make whatever compromises were necessary to do that, but I was noting those compromises. And when I encountered friction, I was noting that friction. And that was really useful. So, for example, I might say, I'm only going to do assessments for females to begin with. That simplifies things. But while I'm developing that, I'm going to notice that I've got these two payloads that have got very similar content, but different fields. And that's an irritation to me as a builder of this workflow, because I've got to have two different parsing routines. Why would we make our users do that? Or I've got these two fields, which have got exactly the same kind of values they could have, but then named differently. Why would we do that? These fields are identical, or the opposite, they're named the same, but they have different values. Why would we do that? So I was getting test ideas that I could feed back to the developers while I was building against the API. Once I've got an end-to-end system, I was more interested in surveying the space around any particular assessment that I was following. So in this mode, I'm more interested in making assertions. And the kind of assertions I can make might be, for any given response, I want to check that the response conforms to a particular schema. I might say, from this point in the assessment, I'm going to send a bunch of requests that I expect to error, and I'm going to check that they do. Or I might make speculative assertions, like I have the hypothesis that this thing should be true at every place in the assessment. I'm going to assert that, and I'm going to run 1,000 assessments, and I'm going to see if it's true. If I find any evidence, actually, I'm going to see if I find any evidence to the contrary. And if I do, well, one of three things: my hypothesis was wrong, and I've learned something. My coding was wrong, and I've learned something. Or the product isn't doing what we think, and now the team has learned something. And the third combination of development and testing starts much more from the testing. And I'm now using development as a tool to help me explore the product from my testing ideas. I come with a question, and now I want to manipulate the walker in such a way that it's going to find data that's going to help me answer my question. So I'll give an example in a minute. What's the longest assessment we could possibly do? As assessments get longer, what impact might that have on the user experience or the back-end performance? I can modify the walker to help me explore that question. So, demonstration. I believe that should start here. Yeah, okay. No? Let's try again. Oh, it did before, didn't it? How do we get a cursor on? How did you get a cursor on this?
If you just, well, let me have a look.
I'll just get down to the play button then. Oh.
So I've got one of these, two of these, haven't I?
So I think it's like to be able to pause it, doesn't it? Okay, well, we're not going to be able to pause it, I don't think. What's happening here is from the service back to us, and you can see an input card as it scrolls up. That's going to give a random string. You probably saw something like an emoji character. I wouldn't necessarily run every assessment like this, but I made the walker be able to dump this kind of stuff to the string. It was often useful to be able to just get an idea of what it was doing. So I might run 10 or 15 of these manually from the command line like this, and just watch what's going through to get a feel for how the system is behaving in the configuration that I have it at the moment. So from the arrow to the left from the service, arrow to the right from the walker. So here's a choice card. There's only two choices in this one. No, here's a text card, so it's presentational. There's no reply. And at the end, there's a report which gives a list of conditions and the advice. And there's a few different assertions that happen. There's actually a PDF being downloaded at the back here, and we'll check some of that too. Let me give you a few details about the implementation. I found in that exploration phase that I was hacking things in similar ways frequently. So I pulled out the kind of things that I was doing into a configuration file. So it's just a JSON file, and it would get read by the walker when it started, but that meant that I could quickly customize it for any particular run. So what kind of things was I configuring? Well, it is an interesting one. You can put more than one symptom into any given assessment. So you might have a headache, but you might also have pain in your foot or something. And I put a probability of saying no when asked if there are any more symptoms. And by default, that's a probability of 80% of saying no. So roughly speaking, if you set everything up as defaults, you're going to get 1, 2, maybe 3, occasionally 4 symptoms in an assessment, which is roughly what our user base does as well from data from production. But if I wanted to make a really long assessment, I could make a very low probability of saying no. That would ramp up the number of symptoms. And we do get cases through in production where users spend enough time, it's pretty laborious, and they put in 40 or 50 symptoms. So we can model that, but then we can model it a lot, very heavily, not just with one test case, but with random data that explores a lot of potential behaviours around lots of symptoms. And you run 10,000 of these, and you might find there's some outliers, and they might be interesting to look at. I also had a walker write extremely detailed and importantly parsable logs. So the stuff that you saw in the demos described, that's actually parsed out of the log files. And the log files contain all of the configuration, and they contain a dump of state of the walker at the end, plus all of the payloads. And for ease of readability, I also extracted out the text so you can skim it and actually read out the stuff more easily. But why does it need to be parsable? Well, it needs to be parsable because then I can, if I've got, again, 10,000 log files in a directory, I can explore the data. So when I said I wanted the system to be able to point places where I might want to look, this is an example of that. I might want to say, show me information about all of the runs where we ended up in this particular state. What do they have in common? And I could use simple tools, parse that data, put it into spreadsheets, begin to plot things. And probably ahead of me here, you could run this in parallel, and I did run it in parallel. In Python skills to make the Python code run in parallel, and I didn't want to hack the code about too much. So I just wrote a simple bash script to be able to execute the walker in parallel. And the data you can see here is an external runner, calling the thing 5 times, running 2 walkers each time. So, you know, essentially the click of a button, I've got 10 assessments running. And it was very easy then to run the kind of thousands of assessments that I was interested in. Maybe even after each fix, have we accidentally regressed something with this fix? Well, I can't tell you for sure, but I can tell you there's no evidence from 10,000 runs. This is the example I was talking about before. what's the longest assessment and what effects might that have? In particular, might it affect response time? So vertical axis here is response time, and you can see that response time does increase as you do more turns in the assessment. Now, the interesting thing is it takes 17,000 turns to get to 3 times the response time. That's a pretty unusual assessment. And the good thing is, even at this level, it was an acceptable performance. So it's kind of interesting to be able to find that out. And what was even nicer was, in parallel, I could run assessments without super length and check that performance degradation for this wasn't polluting other assessments. And again, because we just weren't running the same case over and over again, I had some confidence that this was a generalisable result. Other things that the Walker found, here's a model of the assessment space again. Running 20 or 30 in parallel for a great length of time, we'd occasionally find a 500 server error, which turned out to be somewhere deep in some services that our service depended on. It took the developers a long time to debug that, and they actually used the Walker to help them get confidence that they had found the issue, and it took several rounds. So, reflection. People often think about test automation as something like this quality control machine on a production line. You run the unit tests, they're green, they're the same test you always did, the product performs the same way it always did, so we're good to ship. I hope you might start to think that actually automation can be maybe something a bit more like this microscope where you can focus in different ways, use different lenses, and look at the product in different ways. But actually, this is the way I like to use test automation. It's a lab bench, and it's full of equipment, and it's customizable equipment, and I can make new equipment and plug it into that in different ways. And when I find something that's valuable, like the parallel runner, I can put that in a box with its own dials on the front, and I can plug that into different experiments later. And adding a randomness means that you begin to explore that possible space. You can configure things and set it off to find places that you wouldn't be able to get to in a month of Sundays if you were trying to do this stuff manually. I was explaining to the developers on my team why this might be interesting, and this turned out to be a compelling way to explain how what I'm doing here complements what we're doing generally. This is the assessment space. Think of it as a minefield now. There are bugs in there, they're the mines. Your unit tests, they just stamp on the same place on that minefield every single time, and maybe they once found a mine, or maybe there used to be a mine there, or maybe it's something you care not to have a mine under again. But basically, they aren't going to find many new mines. With a bit of goodwill, maybe there's some kind of equivalence class around those tests, those unit tests. But stamping one place on a minefield, we've got to be pretty unlucky, a metre away to trigger a mine. And you might do exploratory testing to try and fill in some of the gaps in unit tests. But again, there's still going to be spaces that aren't explored. But the Walker, it does not care. It's going to run around that field, heavy boots, maybe waving its arms and screaming. It's just looking everywhere it possibly can to find something that's interesting. And when the context changes, it's going to do it again. And when the context changes, it's going to do it again. It's a really powerful approach. When I found that 500 error, the developers were amazed, and it was a bit like Star Wars. Great shot, kid. That was 1 in a million. And I was really pleased. Yeah, I'm Luke Skywalker. But the secret is, I took 1 million shots, and I just had to look for the one that mattered. And I'm going to leave you with a message. That's the power of this kind of approach. Very good. I'll take a question.
With the Walker, that's just going around and checking that you can get to everywhere and things don't crash. But are you actually checking the results that you're getting?
Yes and no. So there's assertions. That's kind of why I asked Jonathan the question. There are assertions in all of the states that I can make an assertion. What it's not doing, and I think it's probably important to say, is it's not doing any medical checking. So this is a medical app, but because the Walker makes random choices, it's very difficult to assert at the end of an assessment anything about the diagnosis, shouldn't use the term diagnosis, anything about the suggested conditions. So we did try. Am I okay to talk for a time? We did try. So, for example, we thought, what's a very weak assertion we could make? Could we seed this through the configuration with an extremely benign symptom, head lice? And could we assert at the end of the assessment that you should never get to call ambulance? Okay, it would be extremely weak, but maybe if you did, maybe that would mean that something had gone wrong.
Yeah.
But it turns out that if you run enough assessments, you can get from head lice to call ambulance. There's legitimate medical scenarios where that, based on the other answers that you give to other questions. So we couldn't even make super weak assertions unless we were prepared to accept unacceptable false positives. Yeah.
When you said you were inputting random, were you essentially inputting just random, or was it random, like medical kind of terms that you were inputting?
That's a good question. The walker has no medical knowledge.
Yep.
So for names, it would input a random string.
Yep.
For entering symptoms, I use a little trick. I just input 2 characters, and then the back end would search on the medical knowledge base to see what symptoms matched, and that returned a list, and it would randomly choose from that list.
And just out of interest, follow-up question to that. How long would it actually take you to run those 10K cases or?
Oh, half an hour.
Oh, okay, so very quick then. So if they made a very quick change on the dev side, then you could almost initially just run it again, essentially.
Yeah, exactly. And depending on the level of risk that we felt, I might run only 100 or 200 or something.
So you could scale it as depending on the risk.
Yeah, exactly. Or tune it to look in a particular place.
Yeah. Thank you.
Okay, thank you very much, James.
So just one more thing. So Jonathan talked a lot about model-based testing. There's no model behind this. And I think that's kind of interesting. I thought I could do without a model, but I ended up just encoding loads of logic about the system into my code. And I've actually built another system since then, which has an explicit model. So if you're going to try this, my recommendation would be do build a model, because otherwise you just end up with very tangled logic.
Yeah, I just have one more question.
Yeah,
You
sure.
avoided saying diagnosis.
Yeah.
Is that because it would be a medical device?
It is a medical device, and we are certified by MDR at the moment, but it isn't truly a diagnosis. It's more, these are potential conditions that you may have based on the evidence that's been given, with these probabilities similar to people who gave similar evidence. So it's strictly not a diagnosis. It's an easy word to slip into, but strictly not a diagnosis.
That makes it super relevant to the next talk and my talk at the end of the day, so that's fantastic.